timetable. Since we've lost a bit of time, I will be a bit fast, but try to follow. I'm sure you're going to follow. People do not like chemistry for some weird reason, but I enjoy chemistry, and I want you to enjoy chemistry also. So I told you last time that the fundamentals of chemistry, you have to be able to understand chemistry from the atomic level, molecular level, and ionic level going up. If you don't understand what's happening at a subatomic level, when we say subatomic, where's my cursor? When we say subatomic, subatomic level, what we're talking about, subatomic level, we're talking about what's happening to the electrons, what's happening in the atomic nucleus, what type of bonds are they forming. So if you understand what an atom is, if you understand what elements are, and how different types of elements form to form compounds, you'll be able to follow chemistry very well. And again, remember, you have to make sure to get your chemistry book and sort of write down these notes. So just read through the PDF. You can avoid these complicated drawings here, but write down the definition of what an element is. So, Fabi, have you seen a periodic table before?
Yes.
Yes, so all those elements in the periodic table are known as, they are pure substances. They are pure substances. So elements are pure substances. It's a substance in its purest form that cannot be broken down into any other simpler substances, either by physical means or by chemical means. What do I mean by this? If I have something like salt, or maybe let me say something simple like water. Water is made up of two hydrogen atoms and one oxygen atom. So this is water. I can sort of split water up into its two components, hydrogen and oxygen. So these two are the elements that make up water. Because water is a compound, I've been able to split this water up into hydrogen and oxygen. These two components here, this hydrogen and this oxygen, are known as elements. They cannot be split down into any other simpler substances because these elements are made up of atoms, and an atom is the absolute smallest entity. So you cannot split this hydrogen atom into half a hydrogen atom. These two substances, an oxygen atom, a hydrogen atom, they are elements, they are pure substances. You encounter these definitions maybe in paper 1 or in paper 2, where they'll bring a set of multiple choice questions and say, which of the following is an element? You have to say the correct answer. Which of the following, the following are all compounds except, so meaning you have to be able to identify which ones are compounds, and then you choose the correct answer, which is an element. So you have to know all those definitions. Every single element on the periodic table is a pure substance. It contains atoms. So an element is a substance in its purest form. Know this definition, write down this definition in your book. An element is a substance in its purest form that cannot be broken down into simpler substances, either by physical means or chemical means. So not just chemical means, but also physical means. Are we together?
Yes.
All right, so remember I told you that elements, what if a substance that is supposedly an element breaks down into simpler substances? So if you see something like, this substance looks like an element, but I can break it down into simpler substances. This substance is going to be called a compound. So a compound is a combination of two or more elements. For example, the example that I gave you, water is a combination of hydrogen and oxygen. Carbon dioxide, I'm going to tell you the nomenclature. How are we supposed to name this as carbon dioxide? How are we supposed to name this element hydrogen carbonate? Or this is bicarbonate. So I'm going to teach you the rules of naming these simple covalent compounds and simple ionic compounds. But what I'm saying here is that if something looks like an element, but you can split it up into its individual elements, this is carbon and oxygen, this is hydrogen, carbon, and 3 oxygen atoms. So if a substance looks like an element, but it can be split into its individual elements, that substance is not called an element, but we call that substance a compound. So a compound is a combination of two or more elements chemically combined to form bonds. So yes, this is what I was saying. We call this substance a compound from what I'm explaining. All right, so let's actually look into the actual definition of a compound. I already gave the definition, but we can say a compound is a substance made from two or more different elements that have been chemically joined together. So let me just go a little bit in the future here. The chemically joined together, when we say elements are combining together, we're calling it bonding. Something known as chemical bonding. This is a very important topic in chemistry. So these elements, they are pure. They consist of atoms. So all elements consist of what? Atoms. But the interesting fact here is, Faith, because I want the science to make sense, an atom is very unstable. An atom is very, very unstable. So what do these elements do? Because they want to have stability, they are very unstable. All elements are made up of atoms that are very unstable. They are electrically neutral, but they are very unstable. Their electrons move around everywhere. Because they're unstable, they'll be like, what do I do? I'm so excited. I'm so unstable. What can I do for me to be a little bit more stable? I'm going to find another element and I'm going to form a bond so that I can be much more stable. So that's what happens in terms of forming chemical bonds. Why do atoms form chemical bonds? Why are you learning atomic structure and chemical bonding? Is it because you have no choice and the examiner wants you to uh, draw weird diagrams like this to show either covalent bonding or ionic bonding? Is this some form of punishment? No, it's not a punishment. What the examiner wants you to understand is that all elements are made up of atoms. These atoms are very unstable. For them to have some form of stability, they have to form bonds with other elements. And how do they form bonds? They can either we can either have metals combining with a non-metal, and this is known as an ionic bond. We're going to discuss this in the future. Or we can have two non-metals combining together, and we can call this a covalent bond. So an example of a covalent bond is water, carbon dioxide, etc. An example of an ionic bond is something like sodium chloride, iron sulfate, etc. So if you see a metal combining with a non-metal, that's an ionic bond, metal, non-metal. If you see two nonmetals combining together, we can say that's a covalent bond. And sometimes metals combine together because metals have got a very strong metallic character. We call that a metallic bond. There's something known as a metallic bond. We're going to talk about all these different types of bonding in the future. But what I want you to understand today is that a compound is a combination of two or more elements chemically combined together. Why are they combining together? Because elements are made up of atoms. Atoms are very unstable. So for them to have some form of stability, they are going to form bonds with other elements. Are we together? Have you understood that?
Yes.
All right, please watch this video again over and over, write down the notes, watch it at least 3 times so that you are able to understand this topic properly. So how do I know that, all right, this is an element? If you look at the periodic table, there is something known as periodic trends. Periodic trends, meaning these are just, when we say periodic trends, these are observable patterns that you can find in nature. So if you see a pattern repeating itself over and over and over, you'll be like, that's some form of trend. That's a periodic trend. So we can identify and classify elements based on various features. The first thing that we can be able to classify elements is its state. Is this a solid? Is this a liquid? Is this a gas? That's the first thing that we're going to try to identify, because these elements, some of them are metals, some of them are non-metals. Most non-metals can be solids, liquids, or gases, but metals, like transitional metals, your iron, your nickel, your tin, those are solid. So you can identify its state. And later on, when we start balancing chemical equations, we'll discover that, all right, certain states, solid, we write it as an S, liquid as an L, gas as a small letter G. And if the compounds are dissolved in water, we'll say AQ, which represents aqueous. So we can identify or classify elements as either solid, liquid, or gas. Some of them, if I were to draw some form of periodic table like that, and as we are going from left to right of the periodic table, you will start seeing that there's a loss in metallic character. So here we have got metals. These are your transitional metals, and we also have non-metals. So all these elements in the periodic table and we have like a ladder here of certain elements that have characteristics of both metals and non-metals, and we call these metalloids. So we can classify elements also as metals, metalloids, and non-metals. Including non-metals, we just mean our gases and our noble gases. Also, by their position on the periodic table, this is known as the atomic number in the periodic table. So the periodic table, each element, let's say a hypothetical element X, this doesn't exist, but we use X as a substandard for all elements. This element, all elements are going to have a big number on top, known as the mass number. And they are going to have this small number below there, known as the atomic number. So the atomic number is simply the number of protons in a given atom. And remember, the number of protons is equivalent to the number of electrons. Fabi,
Yes.
please do not hate chemistry. I may be talking like this, but once you watch the video, this is going to make sense. Do not give up. Don't lose me. So I'm going to be slow when I'm explaining this. Let me explain this one more time because I want you to understand this state topic. We can classify elements based on their states. Is it a solid? Is it a liquid? Is it a gas? at room temperature and pressure. That's what this RTP means here, at room temperature and pressure. We can also classify elements as either metals, metalloids, or non-metals. These non-metals include your gases and your noble gases. Or we can classify elements based on their atomic number. This is very important, their atomic number. The atomic number is the number of protons in a given atom. Each element has its own unique atomic number. It's the atomic number that can point out, an atomic number is like, it's like your, what can I say? Something very, have you ever heard of fingerprints?
Yes.
Fingerprints are very unique. Even when you're going for your NRC, when getting your voter's card, they told you to put your two thumbs and say, all right, this is your fingerprint. This atomic number, which is the number of protons, your atomic number, the number of protons, is the fingerprint of all elements on the periodic table. All elements on the periodic table have their own unique number of protons, and this number of protons is known as an atomic number. So hydrogen is going to have an atomic number of 1, oxygen is going to have an atomic number, I think 16. I have to look at the periodic table. So if you look at the small number below each atom, let's say for example helium, which is 2,1. So this small number here below is the atomic number. That's the fingerprint of helium. So a helium atom will only have 1 proton. No wonder if you want to define isotopes easily, you can say atoms of the same element having the same atomic number, but the mass number can change. What's inside the atomic nucleus can change. You're going to be able to understand all these concepts as we go further with the topic. So this is what I was talking about, Fabi. Do you see this diagram?
Yes.
All right, so let me draw for you what's happening here. So an atom has got a nucleus. You can see my drawing.
Yes.
This atom has got a nucleus. What's in the nucleus? We've got protons, which I'm going to denote as capital letter P, and we have got neutrons. So what's inside this nucleus here? Let me then highlight it for you. The thing in green here, what's inside this atom is known as the mass number. The mass number is the number of protons and neutrons in a given atom. Then an atom is going to have electronic shells. That's the first energy level. That's the second energy level. Electrons are simply there to take part in chemical reactions. What's in the nucleus does not move. The nucleus does not take part in any chemical reactions within an atom. What takes part in chemical reactions are these electrons. So this number on top of any atom here, I gave an example of helium, which is 2,1. So meaning helium is going to, in its nucleus there, it's going to have 1 proton and 1 neutron, because there are only 2 things in the nucleus there. But this one here represents the atomic number, the number of protons in a given atom. So if I were to draw helium like this, it would be 1 proton, 1 neutron in the nucleus with 1 electron. So this 2 here, it's the mass number, 2 protons. And this one here represents the number of protons. So here helium only has 1 proton. No wonder there's this Ka1 here. So this Ka1, the number of protons, is the fingerprint of all elements. all elements have got different types of atomic number here. No wonder it's even highlighted there. The atomic number, which is the number of protons. It's the fingerprint. It's very unique to all types of atoms. All right. So I'm sure we've answered this question. We're going to go into details of atomic structure. When we start atomic structure and chemical bonding, you know how an atom looks like, what's the charge of a proton, what's the charge of an electron, what's the charge of a neutron, what's the relative position of a proton within an atom, because those are simple questions that can come. What's the charge, what's the mass of an electron, etc. But for now, what I want you to know is that elements are made up of atoms, and an atom is the smallest component of an element. And that atom is what gives all elements their chemical and physical properties. For now, that's what I want you to learn, that elements are made up of atoms. So far, we've introduced three components. We've introduced atoms, and different types of atoms come together to make elements. And two or more elements can combine together to form compounds. And compounds can either be formed by a metal and a non-metal. And also compounds can also be formed when two or more non-metals combine. So what about molecules? So a molecule is just a combination of, it's just one compound molecule. So for example, this is a molecule of water. So water is H2O. If I were to draw a water molecule, it would look like this. So what do I mean by this? This oxygen atom here will be at the center. So that's oxygen. And we're going to have two hydrogen atoms. So that's one hydrogen atom there. That's one hydrogen atom there. So we can say this is one molecule of water. Then we can combine these molecules of water there to form water, which is a compound. So a molecule is just simply a singular. You know, you've heard of plural and singular, right? So the singular of a compound is just a molecule. So just one tiny thing, like one grain of sand. Sand is sand, right? But what do you call one grain of sand? A molecule of sand. Someone gives you rice, a whole bag of rice, maybe 5 kg of rice. If you just pick out one grain of sand, that's one molecule of rice. That's what molecules mean. They're just like one single thing of the entire compound itself. So water, one drop of water will be one molecule of water. So these terms, you have to be able to know them, because in stoichiometry, when we look at stoichiometry and the more concepts, they will start saying we have to be able to use the Avogadro's number to be able to calculate the number of particles or the number of molecules. Then we have to say, all right, 1 mole is equals to 1.2 times 10 to the power 23 molecules. So we have to be able to understand what a molecule is. So a molecule is just one thing. Are we together?
Yes.
All right. So this diagram here just explains. So please, what is a molecule? Write this definition down in your book. Literally write everything in your book. So there's something that, so molecules are electronically stable. They are very stable. However, there's something that you have to understand in terms of ions. So atoms, molecules, and ions. So ions are just like molecules. They are very small, minute substances. But a molecule is but an ion is a characteristic of ionic bonding, which I'm going to explain when we look at atomic structure and chemical bonding. So here we have got sodium and chlorine. The valency of sodium is 1, and the valency of chlorine is -1. So sodium is going to lose 1 electron, and it will become a sodium plus ion, and chlorine is going to gain 1 electron, and it's going to become a chloride ion. So these two are going to become ions. And because of the electrostatic forces of attraction, we're going to form something known as sodium chloride. So this right here is one positively charged ion. Positively charged ions are known as cations, and negatively charged ions are known as anions. Negatively charged ions are known as anions. No, all right. All right, Fabi, just give me a minute. I'll pause. Let me pause the recording. Let me just shift rooms. Give me 2 minutes. You can get me. All right.
Yes.
Let me just shift rooms. Then I'll re-explain everything. Resume the recording. So again, don't worry about all these terminologies. Everything is going to make much more sense when we do atomic structure and chemical bonding. But for now, I want you to understand that there are 3 types of subatomic particles. We've got atoms, which are the smallest components of elements. We have got compounds, which are 2 or more elements chemically combined together. We have got molecules, which are mostly non-metals, like water, 1 molecule of water, 1 molecule of carbon dioxide. And then we've got these things known as ions, which are charged particles that are formed in an ionic type of bond. When a metal, for example, sodium, loses an electron, and a non-metal, for example, chlorine, gains an electron. So if we lose an electron, we're going to form something known as a positively charged ion, known as a cation. And when we gain electrons, we're going to form a negatively charged ion, known as anions. So have you ever wondered that how come if something is losing electrons, it's becoming positively charged?
Yes.
You have, right? Why? Because do you see electrons themselves? Electrons are negatively charged. Electrons are negatively charged. So if you lose something that is negative, you're going to become more positive, right?
Yes.
And if you gain something that is negative, you're going to become more negative, right?
Yes.
So that's why when a metal loses electrons, it's going to become a positive ion known as a cation. And when a non-metal gains electrons, it's going to become a negative type of ion known as an anion. That's the reasoning behind all this. All right, so these are just examples of certain molecules. And if you see, all molecules are mostly non-metals. So all types of molecules are non-metals. This diagram, you have got no choice. You have to draw it and give certain examples. Like this is a non-metal chloride molecules, a molecule of water. a fluoride molecule, a molecule of oxygen, a bromide molecule, and one molecule of hydrogen chloride. The fascinating thing about this hydrogen chloride gas, if you dissolve it in water, if you dissolve hydrogen chloride gas in water, it's going to become hydrochloric acid. So I'm going to teach you how to name these types of acids, and it will require you to memorize just a little bit. All right, this is another example of a molecule. All right, so sometimes in a multiple choice, they want you to know how different types of elements can exist. So remember, I said elements are made up of atoms, and atoms are very unstable. The only atoms that are stable in the whole world, in the whole universe, are your noble gases. The only atoms that are stable, if you look at the periodic table, that last group in the periodic table, those are known as your noble gases. They are the only ones that are stable. They don't form bonds. They're like, I am happy to be alone. Because they are stable, they cannot form bonds, they can exist as individual atoms. So for example, helium, neon, argon, these are your noble gases because they can exist as individual atoms on their own. They are known as monoatomic. Monoatomic. However, certain atoms cannot exist alone. A good example, we cannot write oxygen like this. Oxygen as an atom, it cannot exist independently on its own. It has to form a bond with another oxygen atom. So it has to form a bond with another oxygen atom to become oxygen like that. So two oxygen atoms, including hydrogen. Hydrogen cannot exist independently like this. It has to form a bond with another hydrogen atom to become a hydrogen atom, a compound, a molecule of hydrogen, including chlorine. So I think these are group 7 elements, the halides or the halogens. So because these cannot exist as single atoms, they are known as diatomic. Diatomic because they exist in twos. So diatomic. Others can form triatomic molecules. A good example is ozone. This molecule is very unique. It's actually one of the only triatomic molecules. There are many, but this one's the most common one, ozone. You've heard of the ozone layer, or the ozone layer where it's been damaged, air pollution, global warming. So the ozone layer is a protective layer around the Earth's atmosphere, and it exists as a triatomic ion. So trust me, you're going to have these, even in section B, they can draw some diagrams like this, and then they say which one among the list is monoatomic, give an example of atoms that can exist as monoatomic ions, then you're going to mention these, give an example of atoms that can exist as diatomic ions, they will mention these, mention one example of a molecule that can exist as a triatomic ion, you mention your ozone. So questions like this do come. Let's move on with our lecture. So I did tell you what compounds are, right? I even gave an example of these two types of compounds. So where's my cursor? This one is a compound that has been formed by a combination of two nonmetals, Hydrogen is a non-metal, oxygen is a non-metal, so this is a covalent compound. We're going to know what that means in the future. It's a covalent compound. And then this has been formed by a metal and a non-metal. So this becomes an ionic compound. And a compound is just a combination of two or more elements chemically combined together to form a bond. Why do they combine together? Because atoms are very unstable, so they'll combine with other elements to have that stability. So this is another example of how two nonmetals combine. There's carbon there and there's oxygen there, and a new compound has been formed known as carbon dioxide. Should I teach this? Should I teach this? Fabi,
Yes.
can I end here for today? I feel like if I continue with this part, you are going to hate me. You are going to hate chemistry
Mhm. Okay.
because we have 37 slides to go through. So for now, I feel like let me end the lecture here so that you understand what atoms, molecules, and compounds are. I want you to read through these slides, buy a book for chemistry, and write down the notes. I'm going to send you the notes on WhatsApp. Then watch the video over and over again so that you understand the basic concepts that I was talking about. Because the next lecture is the naming part. Like, how are we supposed to name ionic compounds, covalent compounds? What are the rules? If I go too deep into naming these compounds and some of these examples, you're going to get lost. You hate me. So let me end here today. Then please try to understand this topic such that by next week, Thursday, when we're doing chemistry, we finish this topic, then we move on to atomic structure and chemical bonding, then separation techniques, then we go into chemical reactions, balancing chemical equations, then we do the more concepts, we do reactivity series, we do organic chemistry, then we start revising past papers. So I've prepared a course outline for you also on how we're going to uh, do chemistry. So let me end here for today. I'm going to send you this recording and the notes. I'll start with the notes. I'll send the notes right now on WhatsApp. Then this recording has to sort of save, then I'll send it via email. Well, okay.
Okay.
All right. Thank you very much. I'll see you tomorrow for
Okay.
English, for English and civic education. All right. And I'll send you the timetable. All right. Bye.